So what is a vacuum tube? These are vacuum tubes. This is a 12AX7 and this is a 6L6. The 12AX7 is called a triode because it has three elements of control. It has an anode, a cathode, and a grid. And in England they call them a valve because basically it is a valve for electricity. So let's say I have a water valve that's like a valve like a fireman would use, okay, a lever valve. So as you drop the lever down, the water would shut off, and as you raise the lever, the water would flow, and that's an amplifying because it takes a little bit of force to move the lever, but you can control a lot of flow in pressure. So that's actually a water amplifier. You're controlling, by the lever, you're controlling the flow of water through here. You can go really slow, or you can increase it faster or slower. So that's why the English call it a valve. On a tube circuit, the anode is always positive. So typically you have a resistor in the anode circuit, and the high voltage comes in here, B plus, or plus B plus, and the cathode would be on the negative side. The grid is the control that controls the flow of electrons from positive to negative. Now I use the theory positive to negative. It doesn't really matter. Some say negative to positive, but if you think positive to negative, then all electrical symbols make sense. Like a diode is drawn this way. A diode will conduct if this is positive and this is negative. So the arrow points the way it would conduct. If the diode is turned this way with positive here and negative here, it doesn't conduct. So it would only make sense that the theory of symbols likes the fact that positive is on the top, negative is on the bottom. So we'll say that current flows from positive to negative for simplicity and logic. Right? So we're going to say positive or negative. Doesn't really matter. We're not into physics here, we're just into electricity. Now you have to have a load in the circuit like this resistor here, because if you didn't have the resistor, as you increase the flow, the current would be so high, would flow so easily and be so high it would burn out the tube. So you always have to have a limiting resistor or load. Now the grid voltage, see, this is positive and this is negative. The more positive the grid is in relation to the cathode, the more electrons flow. So you can control, if you bring the grid voltage down below the cathode, you can stop the flow of electrons through here and it won't flow any electrons. And as you bring the voltage more positive on the grid, the electrons will flow through the tube. There's only a certain range that makes any is useful on a tube, and it's generally below on a negative side compared to the in relation to the cathode. Now, so when we're talking the grid voltage, we're always talking in relation to the cathode. We're not talking in relation to the anode. So if you brought this grid voltage down to a negative voltage below the cathode, less and less current would flow. So we're going to do a test here, and I'm going to show you on a 12AX7 how the grid voltage affects the current flow here through this. So what I'm going to do is set up a circuit where we're using two 9-volt batteries to control the grid from positive 9 volts to negative 9 volts. So basically we're going to have two batteries here, and Going to ground the center of the two batteries, so that's plus, that's plus. Ground the center of the two batteries and put a potentiometer here, or an adjustable control, to allow the voltage to go from to the positive 9 volt side to the negative 9 volt side. So this is negative 9 volts in relation to ground, because these are grounded here and here, and this is positive 9 volts. Okay, and so the grounds are obviously connected in the circuit. Now the heater is always connected to a 6.3 volt AC signal. Okay. So here I've built a test jig with one 12AX7 tube, and I'm using half of an old circuit board, one of my prototypes for the Cathode-Kits, and alright, so I've got it, two 9 volt batteries here connected, and I've got an adjustable bias. Alright, so we're going to, using this layout here. Now, the resistor, the load resistor in the anode is 100K. 100K, which means 100,000 ohms. Alright, no resistor in the cathode circuit, just the way it is here. This is a 25K pot. Okay. Now, when you're working with tube amps, you have to be very careful about high voltage. You can get electrocuted really easily. Any voltage over 60 volts can kill you. Now, on my test circuit, I have a power supply connector, and this is the power supply here. Got the rectifier, filter capacitor, and then over here, over the top of the 12AX7, I have a smoothing resistor and another filter capacitor for this stage. I also have a discharge resistor, a 220K discharge resistor, so that when you disconnect power, it discharges the capacitors on the board, so it doesn't leave a charged capacitor on your board when you turn it off. Now, I've got a power supply already set up here, and it's fully discharged, and so I'm going to connect the high voltage here on this connector, and on this connector it supplies the 6.3 for the heaters. This is the same as I use on these boards over here, the other boards. All right. So here I'm set up with the oscilloscope monitoring the anode output here, and the voltmeter is going to monitor the grid. Okay, the grid voltage. So whenever, now if I'll just, as I turn the as I turn the grid bias more positive, you'll see the anode goes more negative. Okay, so as I turn the grid more negative, the anode goes more positive. So that's showing it's an inverting amplifier. Okay, so I'm going to monitor the grid, and we're going to see at what voltage. So right now it's sitting at minus 9 volts, 9.24. As I bring this voltage here, right now it's sitting at a negative 9.4. As I bring it positive, you're going to see that start to come down. Okay. 9, 8, 7, 6. That's minus 5, so it's going up. Minus 5, minus 4, minus 3. I see. Okay, so around minus 3 volts, it starts to conduct. Okay, so as this voltage on the grid is coming up from minus 9, as it's coming up, now that's in reference to the cathode. So as it's coming up and it goes around minus 3, the tube starts to conduct and draw current through this 100K resistor. Okay, you can see that voltage coming down. As current flows through a resistor, a voltage appears across it. That's Ohm's law. Okay, so I am 9 minus 2, 2.3 minus 2.2, getting close to 0, minus 1.5, minus 1 volt, minus 0.6, and right at 0 volt, you can see it's getting close to full conduction. It's brought this anode voltage down fairly close to its low in the low level here. Now if we keep turning it, it's going to go, okay, so right about, well, that's at about, no, that's about plus, that's plus 0.9 volts. So right about 1 volt positive, the tube seems to be fully conducting. The anode is now down to 4 volts, right down from 180 to 4 volts. So it's conducting quite a bit here. So that's about the maximum. So at a full 1 volt positive, it's going to drop it right down with this 100K load. If the load was lower, let's say a 10K load, this voltage wouldn't be so low because the tube is having a harder time pulling it down because of the heavier load and the higher current. The current would be 10 times as high as it is. And this tube can only control so much current. Okay, we'll look at specs later on the 12AX7 and see what the maximum voltage, maximum current is. But for now, first of all, we're going to talk what is bias. Now, bias is the setting that you've designed the amp to have to set a certain amount of current through the anode and cathode when the amp is idling. Okay, so when the amp is idling and no current and no signal is coming in, it's what current is flowing through the anode, and that's called the bias. This 12AX7 is called a Class A stage, which means the AC signal comes in here as a wave, and it's and on the output you see the same signal but larger on the output, and so you're seeing the whole signal from plus to minus appear on the output from plus to minus. Now on the output of a Class B amp or a push-pull amp, you have 2 tubes. One handles one half of the signal, one handles the other half. So one tube would handle the negative going swing, and one tube would handle the positive going swing. And so those are biased differently. They're biased to sit at a very low current, so they only come on for the cycle they're set up for, either the positive or negative. The Class A amp is biased in the middle, usually close to the middle. So there's 2 ways of biasing through the grid bias, where you vary the voltage to the grid, or you vary the voltage to the cathode. You fix the cathode and you set the grid at a certain voltage, or you fix the grid and you set the cathode at a certain voltage. Okay. So anyway, we want to bias this circuit at about midpoint. So if we've got 180 volts here, we want about 90 volts here. So what I'm going to do is I'm going to put the voltmeter on this, on the anode right here, and I'm going to bring it up until I adjust the volt bias until I get about 90 volts. $89.8, that's about as close as I'm going to get, okay? So what I'm going to do now is I'm going to measure what the grid voltage is to require that 90 volts. Okay. So with a grid voltage of minus 0.955, that gives us a midpoint here, okay, on the anode. So we want the grid voltage to sit at minus 0.955. minus 0.955. All right. So with this circuit, we are going to keep the grid to ground using a 1 megohm resistor, and we're going to let the cathode voltage rise through this resistor to create the bias. So whenever the voltage of the cathode and the grid are the same and you turn the power on, because the grid voltage is the same, is zero, zero causes the tube to conduct a little bit. So what happens is when you first turn the tube on, current starts flowing through here, through the anode and the cathode. Alright, so what happens when you put current through a resistor? You develop a voltage across it. So what happens is a voltage appears across this resistor. So now this cathode has gone up a little bit in voltage in relation to ground, but the grid hasn't. So that puts the cathode above the grid. Okay? And that's what we want to happen. So now the cathode is above the grid, so that creates a bias issue. It turns the tube off. So when you first turn the tube on, it wants to conduct, but as it conducts more, it starts to turn itself back off again because this voltage goes higher than this voltage. Okay, so what happens is it finds its equilibrium and it stops, and that is its bias point. So the amount of, you can set the amount of current flowing through this circuit by the value of this resistor here, and that's called cathode bias. Okay, so let's say at this point we have 90 volts. Okay, we want 90 volts. Okay, so first of all we got to calculate the current through this circuit. Now with Ohm's law, we have if we have 180 here and we have 90 here, that means there's 90 volts across this resistor. Okay? And so with Ohm's law we can calculate the current. V over R and I. I means current. Okay. To find out with Ohm's law any one of these three variables, you cover it, and so current, we want to find out the current through here because the current through the anode and the cathode is the same. It flows through here. A tiny little bit flows through the grid, but it's so small that it's negligible because the grid current is in nanoamps compared to this, which is probably in milliamps. Okay. So we know we have 100K resistor and 90 volts. The current would be 90 over 100K. So in the calculator, we're going to calculate the current through this resistor. 90 divided by 100, 000, equals 0.0009 amps. Okay? 0.0009 amps. 0.0009 amps. Okay? So that's 0.9 milliamps at 90 volts. Okay? So, since the current will be 0.9 milliamps through the 100, it'll also be 0.9 milliamps through this resistor as well, because the current is in a series circuit is the same throughout all the components. So we know that we want, from our test before, to get 90 volts here, we need a voltage here of minus 0.955. Okay? To get, so I'm going to repeat myself, to get the 90 volts at this point, we needed a voltage between cathode and grid of minus 0.955. Okay? To calculate this resistor, now we know the current, we know the voltage, we don't know the resistance. So the resistance equals the voltage over the current. So I'll cover the resistance. So we know we want, so it'll be 0.95, it doesn't have to be a negative, 0.955 divided by 0.0009 equals 1,061 ohms. Okay. So V over 0.0009 equals 1,061 ohms. Okay. So this resistor, if it's set to 1,000.61 ohms, it should produce approximately 90 volts, enough bias to produce approximately 90 volts here at the anode. Okay. So I'm going to put a 1K resistor in there. I only have a 1K, and we'll see what it gives. Alright, so I've installed a 1K resistor in the cathode circuit between the cathode and ground, and I've also disconnected the battery voltage to the grid. So it's just this circuit here, basically this circuit here. Okay, so I'm going to check the voltage at the anode. We wanted 90 volts, but I'm going to check it with the voltmeter, and is 94.7 volts, which is pretty close to 90. That's within 5% of what I calculated. So anyway, this is how that's one way of calculating your cathode resistor to get the bias you want for this stage. Now this stage can be any of your preamp stages. It can be, they all, depending on, so you'd first of all know what your voltage is, your load resistor, and then you could calculate the resistors. Now a lot of Fender amps, they always use a 1.5K here for the cathode resistor, but it depends what your B plus is. If Fender amps run fairly high voltage, so probably this resistor is going to need to be a little higher for the higher voltage. So depending on what your power supply voltage is, this resistor will vary, but it also depends on what this resistor is, your anode resistor, because if the lower this resistor, the higher the current's going to flow through. This resistor on amps is typically anywhere from 68K to 220K. On an input stage, you might be running a 220K resistor here to give a more voltage gain. You'll get more voltage gain from a higher value resistor here, but you also get less output drive, because this is going to drive the next stage. Okay, your next stage could be a tone stack, or it could be you're driving another tube. So the tube pulls the negative side down, no problem, but what pulls the positive side up is just this resistor. The tube releases, and this resistor does all the work. So if you had, so the output impedance has to be taken into, your output load has to be taken into consideration on picking this resistor. So if you are driving a very high input impedance load on the next stage, this can be a high value resistor. But if you're driving something that has a number of capacitors and resistors, like a tone stack, you have to lower this resistor so that it equally has enough pull upwards as it does downwards. Another way of finding out what the resistor is for your cathode is to just put a 5K trimmer pot in place of where the resistor goes, and with the voltmeter on the anode, adjust the resistor until you get your desired voltage on the anode, then turn the circuit off, and with an ohm meter measure what the pot is, and then substitute it with as close a resistor value as you can get. That's kind of a shortcut way of doing it. So that's the end of this video. And if you like what you see, or you have any questions, put them in the comments. And don't forget to hit the subscribe button. Let us know what you want to see. Alright, thanks a lot. See you next video.